Solve the initial value problem. dy over dx is equal to x times e to the negative x. So when x equals 0, y is equal to 1. Well, this is a separable differential equation, which means we can multiply both sides by dx. And now we can integrate. So the antiderivative of 1 is just y. And for this one, you have to use integration by parts. So we're going to let u equal x. That means du is dx. dv is e to the negative x. And v is negative e to the negative x. So we're going to multiply u times v, which is negative x times e to the negative x. And then minus the integral of v du, which is just negative e to negative x dx. Now the two negatives are going to turn into a positive. So we simplify. We have y equals negative x e to negative x minus e to negative x plus a constant c. Plug in the initial condition. So if x is 0, y is equal to 1. Well, 0 times e to the 0 is just 0. Negative e to the 0 is negative 1. So we have 1 is equal to negative 1 plus c, and so c is equal to 2. So the final solution is y equals negative x times e to negative x minus e to negative x plus 2. Okay, next problem, we want to set up a differential equation that models the problem situation. So we have a city with a fixed population of p persons. So p is our population. The time rate of change of the number n of those persons infected with a certain disease is proportional to the product of the number who have the disease. So n is the people that are infected, so I should say that n have the disease, and so it's proportional to the product, so product meaning multiply, of the number who have the disease, so n, and the number who do not. So if you have this whole population, n of them are infected, so then p minus n are not infected, because the total of this is p. So the total population is p, n of them are infected, that means p minus n are not infected. So this symbol right here means proportional. Now to set this as an equality, we're just going to replace the proportional sign with equals, and then we're going to put a constant. And so that's going to be c times n times p minus n. And so this is our differential equation.